His name was Alex. And when his trainer, Irene Pepperberg, asked him, "How many?" while pointing to a tray of blue keys, he would respond with a clear, synthesized voice. If there were 6, he would say 6. This wasn't just mimicry. Alex, an African gray parrot, could correctly identify the quantity of up to 8 different items. But what does it mean for a bird to count? Is it the same as when you count? When you see 3 apples, you don't really count them, you just know. This is called subitizing, an immediate perception of a small quantity, something you share with birds, bees, and even fish. Counting, proper counting, is different. It's sequential, it's abstract, and it seems to be deeply connected to space. Imagine a line in your mind. Where is the number 1? Where is 1,000? For most people, smaller numbers live on the left and larger numbers stretch out to the right. This isn't just a human quirk. Newly hatched chicks, when shown a screen with 5 dots, will consistently walk to the left to find a reward. If shown 20 dots, they walk to the right. They arrive in the world with a mental number line already built, linking quantity to spatial direction. Why space? Your brain didn't evolve to do calculus. It evolved to navigate 3-dimensional environments. The neural hardware for mapping your living room, specifically grid cells in your entorhinal cortex, creates a cognitive map of the world. What's astonishing is that your brain recycles this GPS system to map out abstract concepts. Thinking about the relationship between ideas uses the same neural pathways as thinking about the relationship between places. Your mental number line is, in a very real sense, a place your mind can visit. This ability to map concepts allows for profound cognitive leaps. Consider the number 0. It's not a number of things, it's the idea of an absence of things. For human history, it was a revolutionary concept. Yet, honeybees seem to understand it. When trained to fly to a panel with the lesser number of shapes, they will correctly choose a blank panel over one with a single shape. They treat 0 as a quantity, placing it correctly at the very beginning of their mental number line. An insect brain, smaller than a grain of rice, has grasped the concept of nothing. This abstract thinking extends beyond numbers into time. New Caledonian crows, famous for their intelligence, can solve multi-step puzzles. In one experiment, a crow needed a long stick to get food out of a tube. The long stick was locked in a box. To open the box, it needed a short stick. The crow, without trial and error, would fetch the short stick, use it to get the long stick, and then use the long stick to get the food. This isn't instinct, it's a simulation of the future, a plan. It's thinking in a sequence. A leads to B leads to C. Perhaps even more profound is knowing the limits of your own knowledge. This is metacognition, or thinking about thinking. Dolphins have been shown to display this. In an experiment where they had to identify if a sound was high or low-pitched, they were given a third option, an out. When the tones were easy to distinguish, the dolphins always answered. But when the tones were very close and ambiguous, they would frequently choose the out, accepting a smaller, guaranteed reward rather than risk being wrong. They knew they were uncertain. So, is a dolphin that knows its own mind smarter than a crow that can plan for the future, or a parrot that can count? This question misunderstands intelligence. We are judging them by our own metrics. The biologist Jakob von Uexküll called it the Umwelt, the unique perceptual world of an organism. A dog's world is built of smells we can't imagine. A bat's world is a 3D map of echoes. Asking if a bat is smart because it can't appreciate a painting is like asking if you are smart because you can't navigate in total darkness using sound. Intelligence isn't a ladder that we stand atop. It's a vast, branching tree of different cognitive tools, each shaped by evolution to solve different problems for surviving in a different reality. The bird that can count to 8 isn't demonstrating a primitive form of human math. It's demonstrating a perfectly evolved avian intelligence. It possesses exactly the cognitive tools it needs to thrive in its world. The question is not how smart animals are, but how we can be smart enough to appreciate the vast diversity of what it means to think.
Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.